Good morning. Myself Vijay Sharma. Today I am going to explain you the most important chapter of class 12, that is Haloalkane and Haloarenes. It's a very interesting chapter as well as a very easy chapter, so you can easily score good marks from this chapter. Okay, so let's start. First, I'm going to start with the introduction of this chapter. So I'm going the simple example. Let's see. My name is Vijay Sharma. What is my name? My name is Vijay Sharma. In generally, you found a lot of person, they may have a name Vijay, but there is a might possibility they have the same surname, that is Sharma. So here Sharma is indicate that I am belong to one family which have a surname Sharma. Okay, so same here. Nothing is special in this word. What is this? Hello. Alkanes you know very well, arenes you know very well. So what is the common thing is there? Halo. Means both are belong from the halo family. Okay. Here halo is mentioned in the front, and generally we are mention our surname in the back side. Okay. So halo belong from halogen. Okay. And what halogen we have? Fluorine, chlorine, bromine, iodine. This is the member of halogen family. If halogen member of halogen family, if member of halogen family attached to the any alkanes or any arenes, so it is known as haloalkane and haloarenes. Got it clear? Okay, now we go for the next thing. First we start the introduction of haloalkane. What is the term? Haloalkane. So if you remember, uh, we can take example CH4, या फिर otherwise we can say RH. What I mention here, RH. If this H I replace by any halogen, so it will convert into RCl plus HCl. R, if I take here CH3, CH3 H plus Cl2 give us CH3Cl and HCl. So what we did here, we replace one hydrogen from methane with the help of any halogen. Here I taken the example of chlorine, so it convert into CH3Cl. So what generalization we can make? Rx. What general formula we can create? Rx. R you know very well, if we remove one hydrogen from the alkane, what is the general formula? CnH 2n plus 1, and X here may be fluorine, chlorine, bromine, iodine. Okay, if such type of combinations is available, so it is known as haloalkane. The other name is alkyl halide. What is the other name is? Alkyl halide. Okay, haloalkane or alkyl halide. Clear? Now we go for the next term, that is haloarenes. Arenes means what here? Aromatic. Generally we represent it AR. Halo means halogen family. What we can represent? Capital X. So when any aromatic compound, just if I take the example of C6H6, when react with Cl2, we can say C6H5Cl plus HCl. Same way, one halogen is replaced by, sorry, one hydrogen is replaced by any halogen. Okay, what happened here, actually one hydrogen is replaced by the halogen. So in generalization we can write like this: ARX, it is haloarenes या aryl halide. What is the another name? Aryl halide. Got it? Haloalkane and haloarenes. I hope both terms is clear for you. No one have any kind of doubt. Okay, now we go for the next thing, the main difference. So what difference we have in haloalkanes? The general formula is Rx. For haloarene it is ARX. Here halogen compound, if a halogen element is attached with sp3 hybridized carbon atom. Halogen will attached with sp3 hybridized carbon atom. In haloarenes, halogen atom will attached with sp2 hybridized carbon. Got it? The main key difference is here halogen atom is attached with sp3 hybridized carbon atom, and in haloarenes halogen atom is attached with sp2 hybridized carbon atom. Okay, what we learned, there's a simple MCQ test will be there. Just read out the question. What is the name of CH3CH2X? Nomenclature you know very well, what we discussed in class 11th. CH3CH2X. X, that means what? Halogen, yeah, halide we can say. Okay, so halide is available in all the three. Then how many carbon atom we have? 2 carbon. So for 2 carbon, what word we use? Ethane. Yeah, eth generally we can say. So ethyl halide is our correct answer. Got it? Now come on the next thing. In haloalkanes, halogen atoms is attached to. In haloalkanes, halogen atom is attached to which type of hybridized carbon atom is attached? What will be the answer? So answer is sp3. sp3 hybridized carbon atom of an alkyl group. What is the important word you have to remember? You have to focus on that particular term, that is alkyl group. The same thing is mentioned here, but what difference is there? Aryl group. We know if aryl group is there, aromatic group is there, so it will convert into haloarenes. It will convert into haloarenes. So in hurry, some students tick this one, option C, but correct answer will be the option number B. Okay. Let's see one more question. In haloarenes, halogen atom is attached to. So what will be the correct answer? sp2 hybridized carbon atom of an aryl group. Aryl group and sp2. Two terms you have to focus. So our answer will be option number first. Clear? Next, classification of haloalkanes. Now we have a different of haloalkanes we can make. Just like if I take CH4, so it may be convert into CH3Cl. If I remove more than 2 hydrogen, then what will be happen? CH2Cl2. If I remove one more hydrogen, then what will happen? CHCl3. If I remove all the hydrogen, then what will be the happen? CCl4. Some more possibilities there, just like CH3, CH3. This is the normal alkyl group is there. Okay. If I remove one hydrogen from here and one hydrogen from here, so just like CH2 single bond CH2, one Cl group here and one Br group here. Otherwise, we can take both Cl also. So according to the number of alkyl group present in number of halogen group present in compound, या फिर what where the halogen group is attached, in these two things we will classify haloalkane and haloarenes in different way. Okay, so first go with the based on number of halogen atoms. How many number of halogen atoms is attached with carbon? On the basis of that things we will define it. If one carbon is attached, sorry, if one halogen is attached, if one halogen is attached, so we can say mono haloalkanes. If more than one halogen is attached, so what will be the answer? Polyhalogen alkane. So what will be the answer for this one? CH3Cl. For this, replace CH2Cl2, we can say, yeah, we can say CCl4. Here more than one halogen atoms are present. Okay, so this is the example monohaloalkanes. Second one, polyhaloalkanes. Okay, next terms, based on the number of halogen atom. Okay, we can give one more example, just like hydrogen, hydrogen, hydrogen. This is for one carbon. Now if I replace two hydrogen atom, okay, in next example I can replace three hydrogen atom, and further I can replace all hydrogen atom, like that. Got it? Now monohaloalkanes is also classified into the three types. First one is a primary, second one is a secondary, and third one is tertiary. So it's depend on where halogen atom is attached. Where halogen atom is attached. Okay, primary means what? Let's suppose this is the example of methane. Okay, if I remove one hydrogen from here, and in place of this hydrogen I add chlorine atom. What I mention here, chlorine. Okay, so it's a normal haloalkane. If I replace this hydrogen with any alkyl group, means here is also I mentioned CH3, this side hydrogen, this side hydrogen, and this side my chlorine is present. If chlorine is present on that carbon which is also attached with one alkyl group, so such type of halogen, alkyl halide, is known as primary haloalkane. If here is a two carbon atom is attached from this particular carbon, so it is secondary. And if all side carbon carbon is present and one chlorine is attached, so it is known as tertiary alkyl halide. One by one we will see the whole example. First, primary alkyl halide. An alkyl halide in which halogen atom is attached to the primary carbon. Here halogen atom is attached to primary carbon. So see the example. Hydrogen, here I will take CH3, hydrogen and chlorine. Second, CH3, hydrogen, hydrogen and Br. CH3, hydrogen, hydrogen and fluorine I can take. So this is the whole example of primary haloalkane or primary alkyl halide. Okay. Now we go with the another term, secondary alkyl halide. What is the next? Secondary alkyl halide. So in secondary alkyl halide, halogen atom is attached with which carbon which have two alkyl group. How many group? Two alkyl group is attached. Here is CH3, here is also CH3, and this is called secondary alkyde, and this carbon is known as secondary carbon. If any carbon is attached to more carbon, so in a different way, so we can say that it is a secondary carbon. Okay, clear? You can take some more example like CH3, CH2, C, CH3, Cl. Here is a hydrogen. Okay. If you want to name this one, so what will be the name? Chloro, ethane. Then what will be the name? 1 methyl. First 1 chloro, 1 methyl propane. You know very well how we will write the name. Well, we discussed very well in class 11th. If anyone have any kind of doubt, we will discuss it later. Next thing is tertiary alkyl halide. In tertiary alkyl halide, carbon have attached with all three side alkyl group. Okay, means this carbon is attached with three different carbon. Okay, if you replace halogen with chlorine, generally you can mention CH3. It's not compulsory you always mention CH3. You can mention here CH3, CH2 also. Here you can mention CH2, CH2, CH3. This all will count as a 1. This will all count as a 1. This will all count as a 1. Means if this carbon attached with any single carbon, a more number of carbon, the main condition is all three side at least carbon atom will be present. So it will satisfy the requirement. So it is the tertiary alkyl halide. Clear? Next, some MCQ will be there. First, 2-methyl 2-chloropropane. Propane is alkyl halide. We have to find out 2-methyl 2-chloropropane. So how we will draw the structure? Propane means 3 carbon atom we have to draw. Okay. In secondary condition, 2-methyl. Here is a methyl group is attached and here is a chlorine will be attached. Okay. Now we have to check, is it primary, secondary or tertiary? So see, chlorine atom is attached with this carbon and this carbon is attached with all three side carbon. So what will be our answer? Tertiary. So this is the tertiary alkyl halide. This is the tertiary alkyl halide. Got it? Come on, the next questions. It's good for you. Answer is already mentioned. Okay, just go. Which of the following is a secondary alkyl halide? We have to find out which one is the secondary alkyl halide. So what we have to do? First we have to draw the structure. Ethyl chloride. Ethyl means how many carbon? 2. CH3, CH2, Cl. Second is 2-bromopropane. Propane 1, 2, 3 carbon. In second number, bromo is there. If nothing is mentioned, so we will mention this. Okay. So from bromine is attached with this carbon and this carbon